Okay, let's start with interfaces and inheritance in Java. So what we'll start with inheritance first, okay, then you'll get to know what interfaces are and how interfaces are different from classes, what the behavior of interface is. Okay, so let's start with inheritance in Java. The all the classes that we are going to create, they're going to be a subclass of object class. Okay, so one java.lang.object is a class which is defined by Java. Okay, that class is going to be super class of everything. Now the terms super class, subclass, they are something which is familiar to you. Superclass is something which is like created in the very first, like in the beginning. Superclass is there. Then you can have another class which is going to extend the behavior of the superclass. Like let me show you some examples in Eclipse, then you will get to know it better. Okay, in Eclipse, let's create a project to show how this inheritance is working. Inheritance in Java class 1. Okay, let's create a class. Okay, now I'm going to create a class which is going to be like I can call this class shape. Okay, and this is going to be the class name. So let's make it a package name form dot test dot inheritance, and the class name can be shape. So this shape is a class which is going to be the super class of circle, triangle and rectangle. So now you can see the behavior, how like these things are working. Okay, now I'll have a shape class. Okay, this shape class will have some properties like area. Every shape is going to have area. So if it is a triangle, if it's a rectangle, whatever it is, but it's going to have an area. Let's go ahead with that only. Now I'm going to create a class which is called a triangle, and triangle is going to extend the behavior of shape class. Okay, now what happens when you write this thing triangle extends shape, then this area property is going to be inherited into triangle. So you don't need to write area again in triangle, that is automatically inherited. So you will have this thing inherited from shape. Suppose I want to create a circle. Okay, now you can write circle is a class. Okay, that is extending shape. Even circle will have this property that is called area, inherited from shape. So you don't need to write area again in circle. So when you have such similar things and you have lot many classes, you need to create all the classes, you need to define the same property over and again. At that time you can create a super class that is called shape. That super class will have the property, and other classes, these are the child classes, the subclasses, triangle and circle, they're going to inherit the property of shape class. For that we use the keyword extends shape. Okay, this is how like these things like basically they work. So let's create the same thing over here. Let's see how this shape class can like let us understand its inheritance in Java. So what we are going to do is first we are going to create, so this area it will be a float value. Okay, you can have a float parameter and you can make it public. So if it is public, this is accessible to all the classes even if they are outside this class, right? All the parameters like all the methods and classes, even if they are outside from this class, they can access this parameter. So let's create a public float and area equals to, suppose, okay, let's don't give it some value because we don't know the value of area initially. We don't have any concrete classes now. Now I have the area method. Suppose the triangle, it wants to calculate the area, circle even it wants to calculate the area. So this is there is going to be a method in triangle, there is going to be a method in circle to calculate the area. So that method also we can define it over here. So let's define, let's create a method public, suppose float calculate area. You can have this thing, it's going to return you the area value, or you can say like it's just get area. You can like create this. So this method it's something which is going to be available to all the like subclasses. So we don't need to make area public anymore. We can make it private so that we can access the area field using this get area method. So this get area method is something which is going to like return this area value. Let's put the calculate part aside. We can directly assign the value of area, then we can see how the behavior is like behavior is extended to other classes. So now we can return this dot area. So this is going to return you the area value of this class or this object which is calling it. Now if you want to set the value, we can call the setter method, create the setter method. We can use the Eclipse code generation tool that is available in source, and you can go to generate getters and setters. You have already created the getter, so you can go ahead and you can see the set area method is still there. You can check it and you can click on finish. Okay, then it'll create the float like set area method for you. Now we have a shape class which is having a float field, that's a private field, and we have two methods, public methods, get area and set area methods. Now I want to do one thing. I need to create a triangle object. Okay, let's create a new class that's called triangle class. So we can create a class this way. We can put triangle over here. A triangle is there. Now what we can do is we can either say the super class is going to be shape class. Okay, then you can put control and space, it will write the fully qualified name of the class, or you can leave that blank. You can leave that blank, like you can give it object whatever it was. Okay, this way, then you can write that while you are editing the code. So now what we want to do, we want to extend the behavior of triangle, behavior of shape. Extends, then you can use a control space, it will show you whatever all the options available. Let's write it. Okay, now it has extended shape. So in triangle class you already have those two methods, right? So in triangle class, uh, let's create a method which is going to like we can have the initializer in the triangle class. That's what we call a constructor. Okay, let's create a constructor. Let's create a constructor. You can have the constructor, you can write the class name, then you can use control and space, it's going to create the constructor for you. Okay, then suppose I want to set some value of the area. So when the triangle object is created, it's going to initialize with its area value. So how I am going to like set the area value of this triangle? So you can now it was you can call the set area from here, and you can pass some value. Okay, some value over here, and if it's a float value, you need to give float field f over there. So now what has happened, see, this set area method is automatically available because we are extending the other class, and the variables which are public and the methods which are public, they are available here. Okay, now when you create this triangle object, this constructor is going to be called, then the triangle object is going to be initialized with an area of 1, 2, 3, 4.5678. Right, this is what has happened with the triangle. Let's do the same thing with a circle. Okay, I've created the circle, then we need to extend shape. Now it has extended shape, then you can create the circle constructor, and you can call set area the circle over here, and you can pass 222.333. Fair. Now the circle's area has been created, like it has been set. Then we need to test everything that we have written, and let's see what the value is stored in these particular classes which are being called the subclasses. Let's create a new class which is going to test the behavior of inheritance. Test shape, suppose. Okay, this class is going to be executed, so we are going to put a main method over here. Right, we have the main method. Now we are going to create a circle or a triangle, ngle triangle. You need to import that. It is imported automatically because it's in the same package. Triangle equals to new So this is how you create an object. So triangle object is ready. Now what I want is I need to find the area of triangle, right? Because triangle class is extending shape class. So triangle class has the public methods of shape class. All the methods that are extendable in triangle class, they have that. So if you call this extends method like the set method or get method on this object, it's going to call the shape method. Shape class is that object, that method. So let's print sys out, okay, triangle dot get area, right? Similar thing we can do for a circle also. Let's do that thing for the circle. Circle, we can say it's circle equal to new circle. So this is going to be circle get area. Done. Let's execute the code and let's see how it is giving us behavior it is telling us. See, first it is printing the area of the triangle. You can see we have never defined a method like get area inside this triangle class, but we are able to access that method get area over here. It is saying that a circles or triangles area is area of triangle. Now you can write the area. So this is a method which is inherited from its superclass, right? This is one example of inheritance in which you inherit the behaviors, right? There is one more way which we call, there is one more thing in inheritance, that is what we call extending the behavior. Okay, now what we have seen, we have just used the methods that are available in shape class in the child classes, okay, in the subclasses. Suppose I need to extend the behavior of shape class so that the child classes, they behave differently, they behave in a different way. So say for example in the shape class, what is happening, it's going to return you the area that is stored in this class. Suppose a triangle, what it wants is, if you like, suppose circle, what a circle, circle calculation of area logic in circle, that is different how you calculate the area in triangle. So I want to override the behavior, like how the triangle, when you create the triangle object, it's going to ask you for three different things. First thing is, triangle is going to have three things. One is like how do you calculate the area of triangle? We need the base and the height, right? So we're going to need two different variables in triangle. One is int base, int height. These are the two things which is needed to calculate the area in triangle, right? So let's calculate the area int. So we are going to have a float value for area equal to, we're going to calculate it using half into base into height, right? This is the logic of calculating uh, the area. Okay, plot. Now you have the base and height. You need to set those values. Then you need to create the triangle object. So while creating the triangle object, you can pass the values over here. Base, comma, float, height. And you must be remembering these two values, which are just called the parameter values to the method, the constructor like parameters. They are going to be set to these values first. So you can set them here, and when you refer to these values, these are something different. Okay, these values are the parameter objects, and if you want to refer to this value, you need to use the this operator, right? So let's not save this value because these are not needed anymore. While creating the triangle object, you can directly use this approach of like accessing the values. You can create the area, then you can set that set, you can call the set area method that is going to save the area into circle. Then you can use the get area method also. So let's see how we can do that. So this is giving some error, cannot convert from double to float. point f. Now this is converted into float called set area. You can pass the area over here. So this is the logic, like how it is like we are just putting the logic, but till now we have not extended the behavior of shape class. We're just using it. Okay, let's go ahead with this approach first, then we can see how we are going to extend it. So in circle, what you need, you just need the radius. Int, you can have a float radius. Once you have the radius, then you're going to call the setter of circle set area. But how the circle area is calculated, that's the main thing. Int float area equals to pi into r into, so pi is 3.14, right? That's a float value into radius square, radius into radius. Now you have calculated the area of circle. Now you just need to pass that to the superclass so that the superclass can store it. Now you have the circle area also calculated. So let's create two different objects. Now we're going to create a triangle, and the triangle object, when you like mouse hover over it, it will say you that this triangle object constructor is undefined because you have created a parameterized constructor, and the user is like user cannot create a default constructor over here. So user needs to give two values. You need to give the base and height. Suppose I want to give the base as 2 comma and height as 3. So it's going to calculate the area for me. Again, we are going to create a circle with radius as 4. So let's see how like it's going to give us the output. The application can see area of triangle is 3.0 and circle is 50.24. This is how it is going to work. So this is how we have just used the methods. We have just used, like we have just gotten access to the superclass methods and variables, but we need to extend that one, right? Suppose this method calculate area, it's something which is going to be inside this shape. So what we need to have is, we need to have a calculate area method over here. That method will be available to all the shapes. It can be a triangle or a circle also. So let's create a public. You have to make it public so that it will be available while inheriting. Okay, public, it's going to return you float calculate area. So how this method is going to behave? This method will have some default calculation. So suppose you just said me I'm going to create a shape, but you didn't specify what type of shape is that, right? Then the logic of calculating the shape is not defined. So you can generally return the value of shape that you have, this dot value of area that you have, you can return this one. If the client says that I am creating a circle shape, okay, if you are sure about what shape you are creating, in that class you can extend the behavior of like creating the behavior of calculating the area. So in Java, in Eclipse, you can right click and you can go to source. You can see there is one method over here. One in many you can create generate constructors. Okay, delegate methods. You can click on delegate methods. Not delegate, you can override or implement. What is that one? Okay, you override or implement method. So how overriding, how the logic of calculating area you're going to override, you can click on this. It will show you all the methods that are available from superclass. This is the superclass, right? Save. And we want to override the behavior of calculating area. Then you have selected this one, you can click on OK. Now it is saying, it is giving an annotation in Java. This annotation is just like a reference to Java, so that Java knows that there is going to be some difference in the behavior. What we are going to see, that is going to like going to be acted upon differently by Java. So we give this override annotation which says that use this method code rather than the code available in this class, in shape class. So now we have like used this calculate area method, and that is overridden from which class? From the shape class, that is the super class. Now it is calling return the super class area, so it's not doing anything else. it's doing the same thing. We need to put our logic over here. So if it's a circle, then the circle is going to have a property that's called radius. So let's create a float radius. Then in the circle you have the radius. We're not going to do these things now. We're going to save the value this dot radius equal to the radius that you have received as the parameter. So if you click on this, you can see this thing is for this variable is focused. But if you click on this refers to the class particular value. So this is the object's reference. Now we have the radius ready, and you need to put the logic of calculating area over here. So here you are going to put the logic of calculating area. Logic to calculate area of a circle. So how you're going to calculate the area? You're going to float area equals to 3.14 f into radius into radius. Fine. Now this is something which you have implemented in the class, right? This thing is not common, because if it is common of calculating the area of circle, if you made it common, you have put it over shape class, then that logic is available to triangle, and that is wrong. So this logic of implementing this implementation needs to be part of the class, of the base class, or the child class. So this is the logic how circle calculates its area. Then you need to set the area of super class. You can use set area and you can pass the area over here. So now you have set the area of superclass. It's not mandatory, but you can do that. And as this method is saying, you need to return the value. You need to return the area value, right? Then you can return the value over here. Return area. Whatever you have calculated, you can return that one. If you don't want to return it from here, the value that you have created, suppose you have done it this way, you have directly use the code inside this one. It has set the value. Now you don't have an area field, so you can call get area. So this is going to be this is going to call the super class, right? And that area value is going to be returned to whoever is calling this method. Now you have one implementation in circle class. See, the triangle class doesn't show any error. If somebody is creating the triangle class object and is calling get area, it is going to return you the value, like whatever it is going to execute this method of super class, that is shape dot calculate area. But you need to put some value, some sort of implementation in triangle class also. So let's put this logic in triangle class. This logic is like logic to calculate area of a triangle. You don't have the same logic for triangle area calculation. So we need to set it differently. So first you need to have these two values over here, the base and height, right? Let's create these these variables. You have created base, you have created height. Now we have the values ready, like variables ready. We don't have set any values, so let's set them using like this dot set, not set, this dot base equal to the base that you have received, and this dot height is the height that you have like received as a parameter to the constructor. Now I have set the values. Now the second thing is, to when somebody calls calculate area, you need to set the area. So you need to set the area. How you are going to calculate? You are going to use 0.5, that's half of base and height, that is base, and let's give it height. Okay, now you have set the area and you have used the superclass method that is available. You have used you have inherited that class, you have used that. Now you are extending the behavior by modifying the general way this method works. Then you are setting the caller who has called you, you are returning him the area. Now let's get back to our test class. Okay, here now we have created a triangle. The triangle area is going to be like we are not going to call the area of triangle, we are not going to call get area, we are going to call calculate area. And this method is going to act differently for triangle, and also it's going to work differently for a circle, but the method that is available in the super class. So now we can run this method and you can see what type of output it is giving us. Okay, now it's giving the say proper output, right? And if you want to see which area method is called, which calculate area method is called, you can always put a sysout in all the calculate methods. This is the shape and the calculate method. So I can copy this in into all the classes. Let's go to triangle. You have the this is the triangles calculate area method, and you can do the same thing in circle also. So if somebody calls uh, the calculate area method, you can say which calculate area method is called. So now we have created triangle.calculate area, circle.calculate area. You can see when you run this, it will give you some output like triangles calculate area is called and its circles calculate area is called. If we have another implementation of shape, okay, like we have triangle and circle, we can create a rectangle. So let's create another class, a rectangle, which is not going to give the implementation of calculate area. So we are creating a new class rectangle, but we forgot to give the implementation, but it needs to extend first. Extends shape. Now it has extended shape. We have lot many methods. We're going to give it a constructor also. So let's give it a constructor. So rectangles, what they have a base and height. So you're going to create float base or length and breadth. You can do any length and float breadth and the values. Now you can have float length, float breadth. What you are going to do, you are going to set the values. This dot length equals to length, like the length that you have over here. This dot breadth equal to breadth that you have received over here. Now you don't have you have not implemented the logic to calculate the shape, like the calculate the area. So the default implementation is here, it's not calculating. So we can have a default logic of calculating the area, that is like adding 1 to whatever area value you have. You don't have any value, like it's defined, it's defaulted with the default value. When you initialize it, it has the default value. Suppose if somebody is not calculating the area on his own, this method is going to return, like it's going to set the area first to area equal to 0, and it's going to return you that value. So if we don't have any implementation in rectangle, it should, whatever value we give irrespective of the value, it should give us 0. So let's go to test shape and create a new let's create a new object of rectangle. Now we're going to create a rectangle, okay, and we're going to call it rectangle equal to new rectangle. It's going to ask us for two parameters. One is suppose 1 and not 1, let's go at 4, and the second is 6. So we have created a rectangle, but we have here L is missing. Even here the L is missing. Okay, we have created the rectangle object, and then we need to call a rectangle. Okay, area of rectangle is, you can call rectangle dot calculate area. You can see we have not defined a calculate area method there, but still it is accessible. So in this case, when you call the rectangle's area, in that case this is going to call the shape methods, shape class calculate area, and it's going to return us 0. Right, let's run this class and let's see the behavior. Right click and run as Java application. You can see the output. First triangle area is calculated and its area of triangle. This is saying circle. This is shape calculation area of rectangle. It is giving 0, but shape calculate method is executed. So in this case, the triangle calculate area is executed. Here circle calculate area is executed. But in the third case of rectangle, you are having the shape calculate area is executed. So I'll share you the code. It's up to you how you are going to implement the logic of calculating the rectangle's area, how you are going to extend the behavior, So, so that when you call the rectangle area method, calculate area method, we are going to get a proper output, proper rectangles area. Okay, this is generally extending the behavior. Now we are extending the behavior. So for that reason, you can see in the subclasses, public class circle, we are extending shape, right? In rectangle, we are extending shape. We are extending the behavior, the default behavior of shape class. Okay. So any doubts in this inheritance part? Sorry. Right, right. Okay, ping me the question. How overloading is different from
It's 11 o'clock.
overriding? Okay, okay, that question is still left, right? Okay, I'll answer it in the, actually this concept I have not yet told you. That's part of inheritance only. That will come into picture. But in this question and this example, whatever I have shown, do you have any doubt in this part of extending the classes, extending the behavior, how this calculate area is executed, and how this calculate area is delegated from rectangles calculate area? I don't have any rectangle calculate area. Oh, yeah, how it is executed. So those parts, I think you don't have any doubt, right? Okay, now no doubts, fine. So we can move ahead, right? Then we have interfaces.